right, now that Brew supports objects, we can also add object support to our jitter and run assembly code that's using objects. There have been a few changes to the starter code. There was a bug related to default constructors. When I added that code, I forgot to handle the implicit constructor correctly in one spot. That's fixed. The compile visitor did not handle fields correctly if we access them without this. I guess I didn't have a test for that, so that's also been fixed. Get field op and put field op now have the class name of the type they're dealing with. That will probably change in the future once we have inheritance, but for now, they need to know that. You may have noticed that invoke virtual op isn't really virtual yet, right? We don't have inheritance, we don't have overriding, so it's really not very different from invoke static op. Because we're not doing that yet, jitter will not know what type it's dealing with, and there will be no way to figure that out at runtime. So I've just added the target type to the opcode for now. We'll take that out again later. There's a new class called RTLib that has been added to hold our runtime library. We're going to need some support code that just exists as part of the program. This is true in real languages too. So like in C, whenever you compile a program, it automatically links in the runtime library unless you explicitly tell it not to. And it has code for things like allocating memory, just some support stuff that you wouldn't even think about, some startup code that runs before your program begins to execute. We're going to need something similar to that. For now, ours holds the code for malloc. We're going to need to start allocating memory. And there's a get jitter method in the RTLib class that will give you a jitter that already has the runtime library code in it. So if you get the jitter that way and then you assemble some classes, the class code will be able to call the support methods or functions that are in the runtime library. There's a new method in register called offset. It's just a handy method. You can tell it to generate an offset from a register value, and it will give you back a string like EAX plus 12 in brackets. It handles plus or minus and zero offsets gracefully, so you just don't have to keep writing that code over and over. And then several methods have been added to testutil for assembling classes and then checking the results of both the assembly and executing the assembly. There's a check as a method in particular that will remove the runtime library code from the assembly that was generated so we can compare the rest of the program to what we expect without having to repeat the runtime library over and over and update those tests every time we change the library. So to handle objects, the first thing we need to be able to do is allocate memory. We'll do that with a new syscall for malloc. This is not a standard syscall. Usually that's part of the runtime library, not the operating system. So we'll use 1000 as the index for this syscall, so it doesn't overlap with any real ones that we want to add later. The number of bytes to allocate will be passed in EAX, and then the pointer to the allocated memory will be returned in EAX. The syscall handling code we had in interrupt op has been moved to a new class called syscalls because there will eventually be a bunch of other syscalls. So all of that stuff in one place. To handle the new syscall, our CPU needs to be able to allocate memory. Right now, our CPU has memory, and then it has the stack area. We're going to start allocating at the beginning of that memory block, and there's an alloc method in the CPU class that will do that. It allocates a block and returns the address. We're not going to worry about freeing memory right now. Once memory is allocated, it will be marked as in use forever. Freeing and reallocating memory is actually really complicated, so we're ignoring that whole problem for the moment. A field called index has been added to the field class. This is because we need to know the order of the fields in each class if we want to be able to find them in memory, right? So when we get a block of memory that represents an object, we want to know where, say, the field X is in that block, and it will be based on the index of that field within the class. And then jitter needs to be able to convert our class-related opcodes into assembler. So new op needs to call the malloc function in RTLib to allocate the memory for the object. Invoke virtual op right now will be basically the same thing as invoke static op. It's just going to have a hard-coded call to a method in a particular class. And then get field op and put field op will need to index into the memory for the object. So they're going to use ECX to point to the object, and then EAX will hold the value we're loading or storing. And they're going to index off of ECX to load and store the field value. So if it's the field at the beginning of the object, we'll just point to the memory at ECX. If it's the second field, it'll be ECX plus 4. If it's the third field, it'll be plus 8, and so on. So we can index off of that for field access within our objects. And then I have some garbage I forgot to delete there at the end.